Subject Signals and System. Presentation done by Avari Sri Aditya Bharadwaj 24BQ 1A0410. My topic is Properties of Convolution, Associative, Commutative, Distributive. The topics which cover in this presentation are what is convolution, associative explanation, commutative explanation, distributive explanation, and associative property visual demonstration, commutative property visual demonstration, and summary. Introduction to convolution. Introduction to convolution. Convolution is a mathematical operation that expresses how the shape of one function is modified by another function. It is defined as the integral of the product of two functions after one is reversed and shifted. In this convolution, it is a mathematical operation which one function is definitely depend upon the other function. That means one function shape is modified by another function. Important and applications of convolution. Signal processing. We use in signal processing, image processing, probability theory. In signal processing, fundamental for filtering, modulation, and system response analysis. In image processing, essential for blurring, sharpening, edging, detection, and feature extraction. That means blur of the image, edge detection, that means cropping of the image. We can use convolution. In probability theory, used to calculate the probability distribution of the sum of independent random variables. Now we will discuss about the associative property of convolution. What happens in associative property of convolution? The order of grouping in convolution operation does not affect the final result. That means the grouping of convolution in this operation does not affect the final result or the final outcome. What does associative property states? The associative property states that when three or more functions are convoluted, that the grouping of the function doesn't affect the result, which we discussed in the above step. The mathematical formulation is f star g star h is equal to f star bracket g star h. In this order of operation, we will discuss this mathematical formulation later in coming slides with clarity, with visual demonstration also. I will explain there. Order of operations. The associative property allows flexibility in decoding which convolution to perform first without changing the final outcome. We will discuss in coming slide what this formulation and this point indicates. Commutative property. What the commutative property of convolution tells. The order of function in convolution doesn't matter. Here the order doesn't matter. This means an input signal and system impulse response can be interchanged without affecting the output, simplifying system analysis. The main thing that this commutative property of convolution states that the order of function being convolved does not affect the result. In this property also it doesn't affect the result. In other words, convolving function f with function g else the same result as g with f. That means we reverse the function with with the convolution, we doesn't have any change in the final result. That is given in mathematical expression f star g is equal to g star f. This property describes convolution mathematical operations that are not commutative. Mainly mathematical operations that are not commutative. We will discuss in the next slides. Distributive property. Convolution distributes over addition. The property allows complex system to be decomposed into smaller parallel subsystems, enabling modern design and analysis approach. The distributive property states that the convolution distributes over addition when a function is convolved with the sum of two other functions. The result equal to sum of the individual convolution. This indicates this mathematical formulation. That means f convolution g plus h is equal to f convolution g plus f convolution h. Individual convolution. Signal processing form is h of t convolution x of t plus x1 of t plus x2 of t is equal to h of t convolution x1 of t plus h of t convolution x2 of t. We are going to discuss the associative property visual demonstration. In the previous slide, we discussed, I have told you that we discuss with visual demonstration. It is nothing but f convolution g convolution h is equal to f convolution g convolution h, which this star represent convolution operation. F convolution g, when this convolution happens, signal flow representation h is equal to, when this convolution happens, this signal flows convolution. Both paths leads to identical results. We will discuss these two in two different approaches, approach 1 and approach 2. Let's see approach 1, f convolution g, then we will come one output and that output convolution with h. Input, first convolve the input with system 1. We will convolve this input with system 1. Then it passes the result through system 2. Here the system, when we convolve input with system, that means f convolution g, we get one result, and that result we should convolve with h, and that is and then we will come another result, that result is output. When we see the approach 2, that means right hand side of this equation, first combine system 1 and system 2. First we should combine system 1 and system 2. Here systems is nothing but g and h. First we should combine, we should convolve the system 1 and system 2 impulse response, then convolve with input. Then when we combine system 1 and system 2, we get impulse response, then we convolve with input. Now we will discuss about the commutative property visual demonstration. Commutative property visual demonstration. F convolution G is equal to G convolution F. It is simple. It is nothing but reverse. When we reverse signal, when we convolution signal and system or system or convolution, we get a same result. That means signal convolution system gives us to is equal to system convolution signal. The order of signal and system can be interchanged in convolution. System interpretation. Approach 1, as we know, as we discussed in the previous slide, we should discuss the above formula in two ways, approach 1 and approach 2. Approach 1, we taking left hand side, and approach 2, we taking right hand side. Approach 1, x of n, h of n, y of n. That means y of n is equal to x of n convolution h of n. This is input signal through system. That means input signal through system. It is nothing but a input system through system. Yeah. When we discuss about approach 2, that means right hand side of the form of the formula G convolution H F. Sorry. System response through input. This is nothing but system response through input. That means h of n, x of n, y of n. That means y of n is equal to h of n convolution x of n. That is nothing but system convolution signal. And now we will discuss the summary. Associative property, as we know, the formula F convolution G convolution H. That means F convolution. Now we should convolve both the systems G convolution H, and enables flexible arrangement of system components, composition, optimization in systems, cascade systems. Commutative property. When we reverse signal system, we should get same result. F convolution G is equal to G convolution F. Also interchange of system and input, simplifying analysis and implementation in various applications. Distributive property. F convolution G plus H is equal to F convolution G plus F convolution H. Suppose parallel processing of signal and decomposition of signals, decomposition of complex systems to simpler compounds together. These properties from the mathematical foundation for numerous applications in signal processing, communications, and advanced computing systems. Thank you. 24BQ1804010.